Can you see the paper? Your mid-exam question paper. Can you see this?
Yes, teacher.
Yes. Please make a note. Okay. So let me start from here today. Please take a pen and paper and write it. Now, so this question paper, I gave it for some students, and one more question paper, okay, like this, I gave it for another some set of students. Okay, we'll discuss any one. Okay, no need to discuss both. If there is any difference, I will take. Now, this problem, the first problem is finding or solving the Vlsm, variable length subnet mask. Here, I'm not going to solve this problem. Okay, I'm not going to solve it, but I'm going to give you the tips. So what is the tips means? Here you see, they are giving Vlsm, variable length subnet mask. So variable length subnet mask means, see, there are 4 subnets available. Subnet 1, subnet 2, subnet 3, subnet 4. For 4 different subnets available. In the first subnet, how many hosts you have to count? Okay, there is a number of hosts. Okay, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and here one IP address 14. So totally there are 14 hosts available. If you write 13 also, it is correct. It is not wrong. Okay, so number of hosts is 14. Then here you can see in the second subnet, we have only two hosts. Okay, we need only 2 IP address we need. So now the number of hosts is 2 here. Then here also we are having only 2. So 2 hosts we have. So 2 I'm going to write. Then the next host you see here, the next network, 1, 2, 3, 4. So if you write 3 also it is okay, or if you write 4 also it is okay. But most of the students you have given 3, but it is correct. No problem. Okay, nothing to worry about this. Now you can see here I have 14 hosts. Here I have 2 hosts, then 3 hosts. Okay, automatically your subnet mask is going to change. You are not going to have the same subnet mask here. This is called variable length subnet mask. Many students, what you have done, you are all doing the same subnet mask everywhere. Okay, while correction, if a teacher is correcting this paper, so first the teacher will check whether you are having a different subnet mask for everything. Here 2 hosts, 2 hosts. So this and this, it is going to have same subnet mask. But here 14 hosts, so there will be a different subnet mask here. And also here we have 3 hosts, a different subnet mask will be available. So this is the basic concept. What is this? You are not going to do equal, okay, what is it? Subnetting. So equal subnetting means you can have everything same, but you are having, okay, variable length. Okay, that is called fixed length subnet mask, variable length subnet mask. So in variable length subnet mask, every network will have a different subnet mask. In this case, this will have a different subnet mask, and these 2 will have the same subnet mask. Okay, because 2 hosts. And here a different subnet mask will come. This is very important. Okay, many students, some students they have done correctly, but many students in your exam, okay, you have done this as a wrong. That means you are not understanding the concept, the basic concept you are not understand. You go to the video now. In the video, it is very clearly explained. Okay, fixed length subnet mask. What is fixed length subnet mask? You go for the pizza story. I bought one pizza. Okay, there are 4 networks available, 4 members available. I'm going to divide them equally. This is fixed. Okay, you can borrow 3 bits or 4 bits, 5 bits. For everybody, it is equal. For everybody, the same subnet mask will come. This is fixed length. But variable length is not like that. In variable length, what I'm going to do, I'm going to take a pizza. I'm going to ask the first person, how many, okay, you need, how much you need. I need 14. So 14 means I'm going to cut like this. For the next network, how many hosts you want? Okay, I need only 2 IP address. So 2 IP address means only this much is enough. Next, okay, I need another 2. Okay, this much is enough. Then I need 3 or 4. Okay, for you this much. So for everybody, the subnet mask is going to change. Okay, it is not going to be same. Okay, you see the number of bits to be borrowed. How many bits to be borrowed? I need 4. 14 host means you can go for 2 to the power of 2 formula. 2 to the power of 2, 2 to the power of 3, 2 to the power of 4 I'm going. So if I go 2 to the power of 4, okay, it is 2 into 2 into 2 into 2. That means 16. So now you have 4 bits in the host. 4 bits in the host. Okay, enough. So only 4 bit in the host is enough. Then you can do the calculation automatically. This will have a different subnet mask. Okay, this 2 will have the same subnet mask. Okay, because 2 host, and this will have a different subnet mask. Okay, this is the problem. Many students done this mistake. So you see the word Vlsm. Okay, they are not asking FLSM, Vlsm, variable length. Automatically the subnet mask is going to change. This is problem number 1. Okay, so many students, okay, you can go and refer in the video, but I'm telling the point. FL variable length subnet mask means number of host, it will change. Video is available. Kindly check the video. Now, I'm going for the next problem. Okay, hope you are all okay taking the hints. Okay, these are all the revision. Now, the next problem is, see, MAC address is given. I don't know what is the confusion here. This is given in the binary. This is given in the binary. Okay, maybe in exams they may give like this. In your slides we discussed about, okay, we discussed in the hexadecimal format, but here it is given in the binary. So no need to worry about this. So what you have to do, you have to convert this into from the binary to hexadecimal. You have to convert. Okay, how to convert? Okay, go for this 0 0 0 0. This is 0 0 0 0 1 0 0 1 0. This is 2 0 0 1 1. So 0 1 0 0 0 1 0 1. So you make the table like this. Okay, this is 0. This is 1, this is 2, this is 3, this is 4, this is 5. So you make this table like this, then you can write this. This is going to be your MAC address. So in the slides, the MAC address is given in the form of hexadecimal. Sorry, not hexadecimal, in the form of decimal. Okay, in the decimal numbers. Okay, decimal 4 bits, no hexadecimal. 4 bits means hexadecimal, 3 bits means decimal. So here A will come. This is F. Okay. 1, 2, 4. Okay, I'm just converting. Yeah, all ones means it is F. Okay. This is 1, 2, 4. So 4 plus 1, this is 5. This is 1, 2, 4. Okay. 4 plus 1, 5. 1, 2, 4. Okay, this is 5. And this is 1, 2, 4, 8. So 8 plus 1, okay, 9. Then, so 1, 2, 4, 8. So this is 8. So 8 plus 2, 10. 10 plus 1, 11. So 11 means, okay, A, B, C, okay, like that. Okay, you have to write it. So automatically it will come. You will get the MAC address. Then you have to divide this MAC address into two parts. Okay, and in between you have to add, okay, that EFF, okay, you have to add. So this all these things available in our slides, but only this is given in the binary. Only given in the binary, but many students, you have done this correct. Okay, many students, the answer is correct. I finished your mid exam, but I'm just checking because many students send photos. I'm just checking whether it is correct or not. Okay, so I will give it. Now, the next one is, okay, please kindly note down. In exam, they will give the topology diagram like this from the slides. Okay, this also many students they done this correct, but anyway, see what is this means. This is router 1. Are you listening to me? Any one of you confirm through voice? Are you listening to me? Am I audible?
Yes, sir. Yes.
Okay,
Yes,
very good. Now, see what is this? This topology means. Okay, you have to write the what is that? routing table. Okay, I will do it very simple. See, in exam they will give like this. Okay, no need to be scared. Why? First you see 192.168.10.0. This is 192.168.10.0 network. Then 192.168.11.0. This is 192.168.110 network. Then 209.165.200.224. This is this network. Then here it is 10.1.0.0/24. Okay, this is this network. Okay, then 10.1.2.0. okay, network. This is this network. Okay, there are 5 networks available. No need to confuse, no need to be scared. Okay, what is this? See, what is IP address? Means this is .10. That means 192.168.10.10. This is given. This is the IP address for this machine. This is .10. Then here they are giving .1. What is the IP address here? So the IP address here is 192.168.10.1 is the IP address. This is the meaning. They are not giving full IP address. They give only .1, .2, .3 like that. Okay, you no need to afraid, no need to worry about it. Okay, it is nothing. Now you see here 10.1.1.0. okay, now what is IP address for this? 10.1.1. okay, 10. This is the IP address. So they are not giving full IP address. They give .10 here. Now here they are giving .1. What is this? 10.1.1.1. That is the meaning here. Okay, that is the meaning. Now, what I asked means, I asked you to write the routing table for, I think, for router 2. For this router, I asked you to write the routing table. Okay, how to write the routing table? Okay, consider RIP protocol. Okay, now you see, I'm going to write. Very simple. I'm going for routing table of R2. Routing table of R2. Okay. Now in R2, you see 1, 2, 3. 3 networks directly connected. 3 networks directly connected. So very easy for me. Directly connected means C. Okay. What is the first network directly connected? 10.1.1.0/24. This is directly connected. Okay, this is directly connected. Then what is the next network connected here? You can see the next network is C, directly connected. 10.1.2.0/24. This is the second network directly connected. Then third network directly connected. What is this? You can see 209.165.224/30. This network is directly connected. Okay. C directly connected. This is the target. Then you have to write what is the interface. So here definitely this is going to be fast Ethernet. So I'm going to write fast Ethernet. Even if you're not writing, okay, I give mark. But okay, the correct I'm telling. Fast Ethernet 0/0. Then this is connected in fast Ethernet. Okay, FAST. Okay, FAST, fast Ethernet 0/1. Okay, it is not given, but we can assume. You can assume and write. Then this one. Okay, 206.165.200. Where it is connected? It is connected here, and compulsory this will be serial. So now serial 0/0. Finished. Then so we completed 3 networks. Another 2 networks available. I'm going to take, so 192.168.10.0.0/24. This is the next network. Then one more network is also available, 192.168.1, okay, 11.0/24. This is the next network. Now, what we told in the problem is given, you have enabled the RIP protocol. So RIP protocol means R will come here. RIP protocol. Okay, now you see, I am in this router. I want to go to this network means I want to make a jump to this place. Okay, from here to here, I want to make a jump. Now you can see here, this is connected in serial 1/0. And this is also the same thing, serial 1/0. This is the routing table. This is the routing table of R2. Okay, I'm recording this lecture. Previous lecture also I have the recording. I didn't send it to you. I will merge everything, okay, and I will send it. This is okay. So if you think logically, okay, it is nothing. There is nothing available in this. So in a very easy way you can write. That's why I'm going like this. Okay, did you understand? Anybody having any doubt? Anybody having any doubts?
Yes, Mr.
Yes, tell me.
Mr. This question is all wrong with us. Mr.
No. I actually gave marks actually. Even if you try, some students they try, okay. Even if they try, I'm giving the mark, okay. I'm not exactly 100% answer. I'm not expecting, okay. Some small mistakes also I'm accepting that. You no need to worry. But in the final exam, if it comes like this, you have to do it. Okay. Did you understand what I'm telling?
Yes.
Yes. No problem. Okay. Now I give one more diagram. See. This is the diagram. Okay. For router R2 in the given topology, write the routing table. Assume RIP protocol is enabled in this topology diagram. Come on. Anybody? Please write it. For router R2, you have to write the routing. That means you have to write the routing table. Okay. Assume the RIP protocol is enabled. How many networks available? Okay, you answer my questions. How many networks available here? Speak.
Doctor.
How many?
No.
I'm not seeing the comment. Okay, I'm not seeing the chat. Okay, because I have to change the screen. So somebody they are giving 3. Yes. Now you see, this is one network. This is the another network, second network, and this is the another network, third network. Okay, there are 3 networks available. Okay, now what they are telling, they are asking us to write the routing table for R2. Consider the RIP protocol is enabled. Okay, now I'm going for this. Very simple. Okay, what I can do. So let me, okay, write it in this way. Now see, what is this network? First you have to find what is this network. See. 192.158, okay, sorry, 168, okay, can you see the screen clearly? 168.0.51. This is 51, this is 52. So this network is 192.168, okay, 0.0 network. Then what is this network? This is 10.0.0.51, 52 they are using. So this network is 10.0.0.0 network. Then what is this network? You see 172.16.01.02. Okay, this is, you can make /24. This is /8. Now this network is 172.16.0.0/30. Okay, /30 they are giving, so you should not change. /8 they are giving. Okay, 8, 24, 24. I have taken. This is very simple. Comparing with the previous, this is nothing. Okay, now I go to the routing table. Okay, routing table of R2. Okay, so here 2 networks directly connected. So C. Okay, so what are the networks? 192.168.0.0/24. This is the network directly connected. Then here 172.16.0.0. Okay, this is the next network directly connected. Then, so this is connected in, okay, I'm just going to assume this is fast Ethernet 0 by 0, FA 0 by 0. Even no need to write fast Ethernet completely. Then, next one, this is connected in the serial, okay, this is, so serial 0 by 0. Then, the next protocol is the RIP. Okay, so next network 10.0.0.0/8. So for this, I want to make a jump to, okay, and one more thing I forgot, okay, in the last one. If you want go further, okay, this is RIP protocol. In RIP protocol, you will have always 120 as the administrative distance value. Okay, you will have only 120 as the administrative distance value for the RIP protocol. Then how many jumps, how many hops you want to make? You want to make one. This is more accurate answer. Finished. Then what is the next hop means? The next hop is, okay, you can see here serial 0 by 0 they are giving. So here also serial 0 by 0. This is more accurate answer like this. Okay, so the previous one I'm going to change. The previous one also you can change it like this. Okay, here you can write it 90, sorry, not 90, 120 bar 1, 120 bar 1. So 120 is the administrative distance value of RIP. If you use RIP protocol, you will get 120 here. Okay, and this is how many jumps means one jump you want to make. The same thing here. Okay, you can use 120 bar 1. Okay, like this. This is more accurate answer. So this is how you can write your own routing table by seeing the topology diagram. Okay, so hope this will be easy for you. Okay, there is nothing to worry. Okay, follow my instructions, things will become easy. Okay, now, so we are completing lecture number 1 and lecture number 2. That means IP addressing, okay, IPv6. So all these things is over. Now I'm going for the next concept. The next concept is static route. Okay, you can see this is the topology diagram. Okay, in this topology diagram, okay, because why I'm doing like this means I gave different topology diagram for you, but in exam they will ask like this only. These types of diagrams only they will give to you. Okay, you should not be scared. Now, okay, I'm going for the next one. So this is the diagram given to me. For example, in exam, they're asking me to write, okay, write a static route from PC1 to PC3. Okay, PC1 to PC3, write the static route, write the command, create the command for the static route. Now you can see this is the route. Your packet should go like this. Okay, your packet should go like this. Okay, so this is the static route. Okay, now, and also it should come back on, very important. Return also should be there. Many students, they will not write return. So return should also be like this. Now, for this concept, I'm going to write, okay, the command, static route command. Okay, you have done all the labs. Your labs are over, but you have to practice the commands by writing. In exam, they will ask you to only write. Okay, write the commands. Now, so here I'm going to write the static route. Okay, look at the screen carefully. See the IP address. What is IP address of this means 172.16.3.1. Okay, that is IP address. And what is IP address of this 172.16.2.1? And what is this 172.16.2.2? So this is how you have to interpret. Okay, you should not be scared. IP address is not given. No, IP address is given in a different format. See, 192.168.1.2 this is, and this is 192.168.1.1 is this. Okay, now I'm going to write a command for, okay, static route. I'm going to create. Very easy, simple, but the diagram looks big. There is nothing like that. See, now what I have to do means I have to go to the router 1 first. Okay, now I'm writing in router 1. Okay, I'm writing in router 1. Okay, so what is the command? So command is, first thing I'm going for enable. Then next one I'm going for config terminal. So only in the global configuration mode you can do this. Okay, I'm going for the config terminal. Okay, if you want to be very perfect, you can write first one. Okay, make R1. So it will be like this. So if you give enable, automatically it is going to change. Okay, this is very accurate, but no need. But the commands are very important. Then if I use config terminal, then I'm going to get the prompt like this: config. So in the config, you can create the root. Okay, what is the command? What is the command to create means IP root is the command. IP space root is the command. Now, what is your destination? Means I want to go to the destination. This is my destination. So 192.168.2.0 is my destination. Okay, I want to reach this network. Okay, this is my destination. Okay, now what is the next one means? The next hop. I want to make the next jump. So I am here. I want to make the next jump. So the next jump to here, what is IP address? Teacher, IP address is not given. No, it is given. See, 172.16.2.2. Okay, because this is the 172.16.2.0. So this is 2.2. This is the network ID. This is the network ID. This is the IP address. So I'm just going for this place. Finished. Configuration in router 1 is over. Suppose if they ask you to create a default route, create a default route in R1. Create a default route in R1. Okay, now you can see R1 config. Okay, now how to create the default route? IP route. Okay, everything is going to be 0. 0.0.0.0 0.0.0. Oh, sorry, I forgot one more thing. Wait, subnet mask. You have to give the subnet mask here. This is okay. This is your target. This is your target. Then you can give the subnet mask. What is the subnet mask means? You see, 2. Okay, 20/24. 24 means 255.255.255. Okay, so 255.255.255.0. Okay, because it is 24. So this is the subnet mask. So if somebody is asking, okay, if in the question, if they are asking, okay, default route means, you can write the default route like this. Problem solved. Then let me go to the next router. I'm going for R2. Okay, now this is for R1. This is my first answer for R1. Now I'm going for R2. So in R2, okay, I will get the prompt like this. If you are writing the prompt, okay. If you are not writing the prompt also, no need to worry. Now I'm going for the enable command. Enable is the first command. Okay, then I want to go to R2. Okay, I'm going for the, okay, now if you give enable, automatically it will become hash number sign. Now I'm giving config terminal. Okay, then automatically it will become config. Now I want to create. Okay, I reach this place R2. Now from R2 to R3, I want to create the route. Okay, I want to create the static route. So I'm going for the command IP route. So my destination is not going to change. This is my destination. So 192.168.2.0 is my destination. So what is the subnet mask? It is 24. So 24 means 255.255.255.0. Okay, I'm writing here 0. I'm here. Now I want to make the next jump. So what is the next jump means? The next jump is this place. What is this? 192.168.1.1 is the next jump. So if you make the jump, automatically you are reaching, you reach router 3, then you no need to write. So this is, you created the path Okay, one way path you created. Okay, one way path you created. This is how you have to write. Okay, teacher, you gave a different topology, but you are okay. That's why in the lab I cannot give like this. In the lab, whatever we have done is correct, but in the exam point of view, okay, they may give only these types of topology diagrams, and you have to write. Now, so in this case, what we have done, from here to here we reached. Now, please take a paper or please go to the chat box. I need, okay, the command from here to here. I want to come back. So go to R3, write the command in R3. Go to R2, write the command in R2. In R1, you no need to write, you will reach. Did you understand what I'm telling? I need you to write, okay, the static root in R3 and R2 to come back. Okay, do it. I want to see in the chat box. Did you understand what I'm telling?
No, Mister.
No. See, I created the path. I created the path like this. Okay, I created the path R1, R1 to R2. Then from R2 to R3 I created. So it reached the destination. Now I want the packet to come back, reverse. From here to here I want to come back. So I want the command for this. Now try to understand. We created only this we created. Now my packet reached here. I want to write, okay, the command to come back to the reverse. I want to write. Now go to the R3 and write the command. Then go to the R1, write the command. Automatically it will reach. Okay, let me see. Anybody is doing? I want to see in the chat. Nobody. Come on. Right. So your packet reached here. Your packet reached here. Now I want to make a reverse. A reverse. Okay, I want to write the root. So go to R3 first. In R3, you have to write the command. So automatically your destination is going to change now. Okay, your destination will change. This is we have done in the lab. We have done the same thing in the lab. Okay, we send the packet in one path. Then the another path you received the packet. Anybody? Anyone? I need to see. Can you please repeat? Okay, now see. I want to create, try to understand the concept. I'm repeating the concept again. See, I want to create a static root from, okay, PC1 to PC3. Then I want to return the packet back. Okay, so if you create one way, you will reach here. Then for returning also, you have to create the path. In the lab, we have done. In the static, we have done this. Okay, we created a topology. In one way, we send the packet and we receive the packet in another way in the lab. Static root. Okay, now I have done from from here to here I have done, I completed. Now I'm asking you to write it in the reverse. My packet should come back to me. Okay, now it is reached PC3. From PC3 to reply. Okay, I want to get the reply. I want to get the return. Okay, I'm asking you to write the command. Okay, so this is the concept. Now, anybody tried? No one. Okay, no problem. Let me try it. Let me write it. See, very easy. What you have to do, now I'm going for, okay, I want to take the packet back. So the packet should come back. Now you have to go to the router 3. Okay, now I go to the router 3. Okay, first thing, you are in router 3 R3. Okay, I'm going for enable command. Then I'm going to write, okay, config terminal. Now I'm in config mode. Okay, config. Okay, config. Now I'm going to write the command IP root. Now what is I'm here. Okay, I send the packet and I'm going for the return now. So I'm in this place means my destination is now this. Okay, before, while going like this, your destination is this. Now while coming back, my destination from source to Okay, from Sur to Muscat I traveled. Now from Muscat to Sur I want to come back. So now IP route, my destination is 172.16.3.0. Subnet mask is, okay, you can see 24 here. So 255.255.255, okay, .0. Then I'm here, I want to make the next jump. So what is the next jump means? The next jump is 192.168.1. This is the network .2. So 2 is the next jump. This is. So now we are in router. Okay, our packet reached R2. Now I'm going for R2. In R2 I'm going to write. Okay, I'm not writing enable config terminal, all these things. IP route. Now my destination is 172.16.3.0. So subnet mask is 255.255.255.0. Okay, I'm writing here. Now what is my next jump means? My next jump is to this place. So that is going to be 172.16.2.1. Finished. This is the answer. We have done this. We have done this completely in Packet Tracer. The same thing I'm writing here. Okay, the same thing I'm writing here. So hope you understand. Now I'm going for the next one. That's why, okay, please take the paper and write the commands. The video I will share, okay, last class video and this video I will merge and I will send it to you. Okay, now I'm going for the next one. Okay, what is the next one means? See, the same network, the same topology diagram, I'm using IPv6 address. In lab, we have not done IPv6. Suppose if they ask, okay, to write it in IPv6, nothing to worry. Only the IP address you have to change. All the commands, okay, it is going to be same. Now, only the IP address, okay, I'm going to change. Okay, all of you look at the screen carefully. This is something new. Don't be scared. Don't be worried. Suppose if you are getting any IPv6 address, if you get, you no need to worry about it. Okay, teacher, what I have to do? See, this is the thing. They are asking you to create a static route. Are you with me? Are you listening to me? Are you listening to me?
Mr.
Yeah.
This question is do not come in the exams, right?
Which question?
This question.
This question?
Yes.
Which exam you are asking?
Yes, it was in the mid or not?
No. It is not in the mid.
Okay, Mr.
It is not. Maybe in final exam, if they give like this, you no need to be worried. That's why I'm telling. I'm giving the practice. Now, see here. Same topology diagram. They are using IPv6 address. Teacher, what is this IPv6? Nothing to worry. Same concept you are going to follow. See, I want to create a route from, okay, PC1 to PC3. I want to create a static route. I want to create. So what you have to do? You have to create PC1 to PC3. Then you have to come back. Okay, you have to do the reverse. Same concept I'm going to teach now. Whatever we have done in the previous one. Same thing. I will write both 4 and 6 I will write. Don't worry. See. Okay, sorry. Don't confuse. I'll write 6. Okay. Now I am going to write the command. Okay, what is the command? Now I am in R1. See here. I am in router 1. Okay. What I am going to do? Same thing. Enable. Then config terminal. Teacher, you are not writing here. No need, not necessary, because these are the commands. If you write this is also correct. Okay, nobody is going to say wrong. So, sorry. So, enable config terminal. Okay, this is correct. Next command is, I want to create the route. So, IP, same command, IP, okay, IP route. So, now this is IPv6. So, I write IPv6 route. So before I write IP root. This is for IPv4. Okay, this is for IPv4. Sorry. I think you could not see. See, I keep like this. This is better. Now, see, I gave IPv6. I'm using root. Before we write IP root. See the difference. Nothing. V6. I put V6. Now, the next one is your destination network. So what is your destination network means? You can see this is my destination network. Okay, destination network. So my destination network is 2001 colon DB8 colon ACAD colon 3. Okay, I'm just writing this IP address. I'm just writing this, okay, this network /64. This is our destination. This is our destination. Okay, so in the previous one, okay, we wrote like this. Okay, that means in the IPv4, you can see, I will show the IPv4, you will understand. Okay, you can compare both. See, here we wrote like this. How we wrote? See, IP root, my destination is this 192.168.2.0. Okay, then you gave the subnet mask 255.255.255.0. You gave the subnet mask like this because it is 24. But here, if you give IPv6, please be happy. Why means you no need to write the subnet mask. You can write /64. You can write. That's it. So this is my network. So for this network, okay, this is. Now, next one, I want to make a jump. I want to make a jump to this. Okay, I am in R1. I'm writing for R1. So if I want to go to here, I want to jump to R1. Okay, now you go to the previous example, IPv4. See, I want to make a jump to this place. What is the jump? This is 172.16.2. Okay, 2. This is 2.2. This is for IPv4. Now, for IPv6, okay, you see, what is the next IP address? You see, the IP address is, okay, :2. :2 is given. This is your network. So I'm writing that, say, 2001 DB8, okay, ACAD :4 :2. :4 :2. Okay, :2 is given. So you no need to give even /64, no need to give. That's, you can just leave it like that. Okay, because you are not giving anything. You are not writing any subnet mask here. So you no need to write any subnet mask here. You can just simply leave the subnet mask. Okay, no need to write. This is the command. Teacher, I'm not very clear. No need to worry. Don't go for IPv4. I will go only for IPv6. IPv6 is easy. In fact, see, I'm here now. I want to go to this network. Okay, I'm going to write the command. Okay, now you see, I'm going to R2. Okay, IPv6 root. What is my destination? My destination is 2001 DB8 ACAD :3 /64. This is my destination. I'm here. What is my next hop means? My next hop is, okay, see, this is :1. My next hop is 2001 DB8, okay, this is the network, DB8 ACAD :5, okay, :1. No need to write any slash. Finished. So your packet reached in this place. So if you reach R3, automatically you reach the network. Finished. So you created a path, one way you created. Okay, one way you created like this. Now, I want to go back. I want to go, okay, I reached Muscat now. From Muscat, I want to go to Sur. Okay, now what I'm going to do, I go to R3. I'm going for R3. Okay, no, okay, you can enable, first command is enable, then config terminal, everything is same. Now, I'm going for IPv6 root. Okay, IPv6 root. Okay, very good. Now, where you want to go, you are here. You are in R3. I want to go to this network. This is my source. That means I started from here. So 2001 DB8 colon ACAD colon 1 double colon 64. This is the place I want to go. Now I'm in R3. Now next jump. What is the next jump? I want to make the jump to this place. Okay, what is this? This is colon 2 and this is the IP address. So 2001 DB8 ACAD colon 5 colon 2. Finished. So if you get in IPv6, it is easy. Okay, even in IPv4, you have to write the subnet mask. Okay, you have to write what is the subnet mask. But here, no need to write the subnet mask. You can use / unfinish. Now, so we reached R2 now. Okay, I reached R2. From R2, I want to write the command again. IPv6 root. My destination is this 2001. Okay, 2001. In the last class, I told if any IP address starts with 200, that is going to be the global unicast IP address. Okay, that is a global unicast IP address. Now, so 2001 DB8 ACAD 1 double colon /64. Now I'm here. I want to make the next jump. What is the next jump? This is okay colon 1. So 2001 DB8 ACAD 4 colon 2. Okay, finished. This is the IP route. Suppose if they are asking you to create a default route in IPv6, that is very easy. What is default route? See, IPv6 route. In default route, we write, okay, in IPv4, we write 0.0.0.0, 0.0.0.0 we write. Okay, but here it is very easy. IPv6, everything is 0/128. Finished. This is the default route in IPv6. All zeros, all 28-bit zeros. We discussed in the last class. Okay, rule 1, rule 2. So everything is 0. So /28, 128. So this is the default route. Okay, this is the default route. Then you have to give what is the next jump. Next jump you have to give so 200 anyone. Okay, colon DB8. Okay, this is going to be my next jump. 4.4 colon 2. This is the next jump. So this is IPv6 default route. Actually, IPv6 is easy. Okay, for writing, IPv6 is writing. If it's the same thing, if you want to write it in IPv4, so IP route 0.0.0.0, 0.0.0.0, then some IP address will come. Okay, 10.0.1.1. Okay, like this. So same thing I'm writing here. So this is how you can create. Okay, you can create the static routes in IPv4 and IPv6. Okay, in both you can create. So you have to practice. You have to practice writing the commands. Okay, so this is about the IPv4 routing. Okay, that means static route and dynamic route. Okay, now I'm going for the next very interesting problem. This is, I don't know what is the problem for this. So many confusions in this. Yes. What is this means? You have to create, are you with me?
Yes, doctor.
Yes. Now, you have to create a, what is that? Yes. Okay, see, what is the question means? Okay, this question I'm not going to explain, okay, because this is, you can do it. Now, construct a shortest path tree, STF, for the router 4, R4, then populate the routing table for R4. Okay, now I'm going for R4. If this problem comes, you have to enjoy this. See, I'm going for R4. Okay, this is R4. For R4, you have to create the shortest path first tree. Okay, now some student they gave tree like that. Okay, I'm not reducing the mark. I didn't reduce the mark. I gave, okay, depending upon the try how you are making. So now I go for R4. Okay, I just make a table. Okay, I'm making a table. So here, this is for R4, SPF, shortest path tree of R4. Okay, let me check it. Is it R4? Yes, R4. Now, so what I'm going to do means, from R4, you have to find all the destinations. All the destinations means, see, this is, I'm here, I'm in this place. Okay, so 10 dot, okay, you're right. First one is the destination. First one is a destination. Then the next one is the path. Okay, next one is the cost. Okay, you can refer in your slide, you will find it. Now, see, I want to find all the networks, and then I'm going to find the cost. Okay, now you see, next one, first one is 10.8.0.0.16. This is first destination, first network. So I write 10.8.0.0/16. This is my first destination. So what is the path? Path is, it is directly connected. So this is R4. It is directly connected. The cost is 2. Okay, this is the cost. Then the next destination, you can go here or here, anywhere. Let me go here. Okay, I'm going here. So now what is this means? 10.0.0/16. Okay. Just a minute. 10.8. Yeah, this is 10.10. Yeah. See, 10.10.0.0. Okay. Now for this, how can I go this? Means I can come like this, or I can come like this. Okay, I can come like this. Okay, there are two paths available. So what I'm going to do, directly from R4 to R5, you can go like this. This is one path. So what is the cost of this path? The cost of this path is 10. Okay, 10. I have another path also for this. What is another path means? From R4 to R1, then from R1 to R2, then R5. Okay, and okay, this is the next path, R5. Now, what is the cost? You see, 20 plus 20, 40, 40 plus 10, 50, 50 plus 10, okay, 60. So 60 is the cost. So for 10, I have two paths. Then let me go to the next network. I'll take this one, 10.4.0.0. So this is the next network. I want to go here. Okay, what is the path? So the path is, you can have four paths. Okay, from R4 to R1. Okay, this is the one path. For this, what is the cost? The cost is 20. Then what is the next path means? You can go like this, R4 to R5, then from R5, okay, like this, and you can come here. So R5 to R2, R2 to R1. Okay, this is the next path. What is the cost? You can add everything, 10 plus 10 plus 20 plus 40, 40 plus, okay, 40, 50, 60. So the cost is going to be 60. This is the next one. So I'm going for the next network. Next network here is, you can see, 10.11.0.0 network. Okay, actually 10.0.0.11. Okay, so now I go for 10.11. So now what is the concept? For from here, you have to go for all the networks. Okay, in different paths. So all the different paths, if I write, that is called the shortest path. Sorry, shortest path tree, complete. Now from this, I'm going to choose only the best. So I'm going to choose this. This is the best. Then from R4 to, okay, R1, R4 to What is it? Sorry, R4 to R5. Okay, see, from R4 to R5, there are two paths available. So this path I'm going to remove. This is very expensive. This is I'm going to take. So the next table is going to selecting only the shortest path from this. Only the shortest path they will select and make the table. This is the shortest path concept. Okay, so from one network you take any one. Okay, suppose you see this is the example given for you in the paper. That means in your slides. Now you see 10.5, 10.6, 10.7, 10.8, 10.9, 10.10, 10.11. They are taking all the networks they are taking. Now R1 to R2, R1 to R3. They are taking only the shortest path they are taking. So before making shortest path, okay, you have to select everything, all complete you are collecting. So this is the complete thing, then you can make. Some students, they have done the second part correctly. Some students, okay, they tried this, okay. In exam also, you no need to worry. All options, teacher, I want to try. No need. At least some options, if you try, it is good. But the shortest path, if it is correct, it will be good. You understand what is the concept now? Did you understand the concept?
Yes, Mr.
Yes. So this is how you have to work in this. Okay. Don't be scared and no need to be worried. Okay. So this is what I want to say in your in the mid-exam part. Okay. Now let me go to the next problem. Okay. The next problem is, you can see in the OSPF. Okay, in the OSPF, I'm going for the OSPF now. I'm going to write the OSPF. Okay, then I will come back to you. Okay, now let me go for OSPF. Okay, just give me 1 minute time. Okay, one more problem. Before OSPF, I'm going to show this problem. This problem in class, okay, I didn't explain this properly. I explained actually, but we didn't solve any example. Okay, let me solve some example for this problem. Right. Yes, now take a paper, okay, and write. Maybe you may get a question like this. Okay, maybe find, okay, see, matches for the packet desin to 172.16.0.1.1. Okay, now this is the destination network. I want to go to this network. Okay, I want to reach. This is my destination. Now I have three routes. This is route number 1. This is route number 2, and this is route number 3. Okay, you see, these are the three different routes available. There are three different routes available. I want to reach this, my destination is this. Okay, we wrote it now in the IP route. Okay, IP route. My destination is 172.16.0.10. Then you have to write the subnet mask. Okay, so this is my destination. If I want to go to this destination, suppose there are three routes available. What are the three routes? You see, 172.16.0.12. This is one route. 172.16.0.0.18. This is my second route. Okay, then this is the third route. Now, which route, okay, your protocol, that means the routing protocol will select. This is the question. Okay, which route the protocol will select. Okay, they may ask in any method, but this is the concept. My destination is 172.16.0.10. This is my destination. Okay, and there are three different options available, three different routes available. So which one will be selected as the best route? Which one will be selected, okay, as the best route? Okay, this is the concept. Now you can see this 172.16.0 and 10. I'm converting into binary. Okay, I'm converting this into binary. Okay, this is the binary value. So this is the binary value for everything. Maybe in exams they will give binary values also. Now, what is how you can select the best, okay, whether I can choose the route 1 or route 2 or route 3. Okay, try to understand. See, I am in this place, I am in this router. Okay, I'm in this router. I want to go to Muscat. To go to Muscat, there are 3 paths available here. Okay, my car is available here. I'm here. Okay, in this router. There are 3 different paths available to go to Muscat. Now, so which path I'm going to select? Okay, which path I'm going to select? Same thing. So this is my destination, 172.16.0.10. This is my destination. I have 3 options, 172.16.0.0. This is one option, this is a second option, this is a third option. Okay, you see, only the subnet mask is changing. Okay, only the subnet mask is changing. Okay, now how you have to select? How the routing protocol will select means the routing protocol will select the last one it will select. Okay, the routing protocol will select, okay, the last one it will select. Why, teacher? Why it is going to select the last one means the last one you see here, this is called the longest match. This concept is called the longest match to the IP destination. What is the longest match? See, I have 1010 here. The same thing available here. Then next one I'm having, okay, 000. So there is some, okay, the same thing is available here. So 8 bits matching. Here 8 bits is matching. Okay, totally 8 bits matching. Now, next one is I'm having completely, okay, I'm having, okay, see, all are 8 bits available. The same thing, I have 8 bits available here. Okay, 8 bits available here. Okay, so now this is, wait 1 minute, they are confusing. Okay, now you see here. So 26 means, see, this is 8 bits matching with me, and this 8 bits is matching with me, and this 8 bits also matching with me. Okay, totally 26 bits. This is the network part. Now, if you take this 8 and this is also matching, so totally how many bits matching here means for this and this, there are 26 bits matching. Matching means same. Now, I go for this. Here, how many bits are matching? See, the first 8 bits are matching, and then the 8 bits, and then only 2 bits, okay, because here it is going to be 18. So 18 means here only 18 bits are matching. Very simple, okay, whatever the big you have to select, that's it. Now you see, this is 8 bits, and this is 4 bits. So here we are going to have only 12 bits matching. So now, which is the best one means this is the best you can select. Teacher, what is this, teacher? Nothing, teacher. Very simple. Whatever the having the subnet mask big, it will match. Finished. Understand? Or want to repeat? Anybody? Is it clear? Are you listening to me? Is it clear?
Yes, doctor.
I will give one problem. Please find the answer. Nothing to find the answer here. Okay, this is a stupid question. See, I'll write answer. Okay, I'll write one problem. Find what is the answer for this. See, 195. Okay, hope you are seeing 195.20.16.60.0. This is my destination. Okay, I want to go to this network. I have 4 options. 195.20.60.0/24 I'm having. 195.20.60.0.25 I'm having. 195.20.60.0/27 I'm having. So which one you will select? Which one will be the best path? Which one will be the best path? Speak. Which is the best path? A or B or C? This is your destination. You have 3 different paths. So which one you will select as the best? Which one you will select as the best? C. Okay. I'm saying the comment. Okay, chat box. Very good. This is okay. This is what they are explaining there. Okay, keep this in mind. Okay. Now I'm going for the next one. So the next one is OSPF. Okay, we are going for the OSPF. You have done a exam in that, okay, a lab exam, but still, okay, I want to show you some basic things, okay, in the OSPF. Okay, see, maybe in exam, they will give the topology like this. The topology diagram will be like this. So no need to be worried or be scared by seeing this. So I already explained to you how you can find the IP address. Okay, see, R1, R2, okay, sorry, R1, R3, R2. There are 3 routers available. Okay. If you go for OSPF, in OSPF, we discussed 2 concepts. What is that? One is single area OSPF. Single area OSPF, okay, we discussed. Then, second one is multiple area, okay, or multi-area OSPF we discussed. Okay, single area OSPF, multi-area OSPF. There are 2 things we discussed. Now, if you go for single area OSPF, you must have area 0. Okay, that means in single area, okay, you must have, okay, area 0. In multiple area, all the areas must be connected with 0. Okay, all the areas must be connected with 0. This is very, very important, okay, point. Now, you see, this is a multiple area. This is area 0. They make this as the area 0. And then this one, they make area 1. And here they make this is area 2. Okay. Now, if you are going for OSPF configuration, a very important thing is you must know the router ID. They will give the router ID. Okay. They will give the router ID. Okay. Now, I'm going to write the command here. Okay, I'm going to write the command IPv4 command to enable, okay, the OSPF in router 1. Okay, so very simple. What is the command? So first command is enable. Okay, I'm in R1. You have to practice like this, R1. Now, next one is config terminal. Okay, then config terminal. Then the next one is, okay, I'm inside the router now. So the next command is router OSPF. This is the command. OSPF. Okay, now we have to give, okay, a ID. That means a number. They will give you a number here for you. Okay, so that is the process ID. Okay, that is called the process ID. So 10 or 20 or 30, they will give it, okay, in the paper. Then the next one is, okay, now I am inside the OSPF. Next one is, I want to define what is the router ID. So the router ID. So you see, what is the router ID here means, okay, they didn't give any router ID. Okay, I'll make it as 1.1.1.1. Okay, so router ID, I'm going to make this as 1. In exam, they will specify the router ID. Then, next one is, you have to mention what are the networks directly connected here. So I know 1, 2, 3. So 3 networks directly connected. I'm writing 3 network. Definitely 3 networks directly connected here. So what is the first network? You can see this is the first network, 10.1.1.0. Okay, so that is the first network. Now you are seeing 24. So here you have to use the wildcard mask, not the subnet mask. Okay, you have to use the wildcard mask, not the subnet mask. What is the wildcard mask? So here 24 available. What is 24 means? So the opposite, 24 means it is 255.255.255.0. This is 24. 8 bits. 8 plus 8 plus 8. Now you have to go for the reverse. So reverse means 0.0.0.255. Okay, so you have to give it, okay, you have to give the wildcard mask. Then what is the area you have to mention? So this is going to be available in area. Okay, they are giving area number 1. So area 1. This is correct. So this is how you have to write the command. Now let me go to the next one. There are another network. So 10.1.2.0 network. Here the subnet mask is 254 they are giving. So 254 means 255, 255, 255, 0. Wildcard mask. So wildcard mask is going to be 0.0.0.255. This is also going to be in area 1. Area 1. Then, so 2 networks we completed. Go to this network. This is the next network is 192.168.10.0. So here they are giving 30. Okay, they are giving 30 here. So this is, you have to be very careful here. So 30 means only 2 bits left. Only 2 bits left. So what is 30? Okay, I'm going to convert this. We have done in the last class. So /30 means what is the subnet mask? So this is equal to 8 plus 8 plus 8 plus, okay, 24 plus 6. Okay, so 8 plus 8 plus 8, 24, 24 plus 6 equal to 30. Okay, so this is 255 plus 250, okay, not plus dot. So 255 dot, here they have taken 6 bits. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 bits they have taken, only remaining 2 bits available. Now, how I can convert this binary? Very easy. 255 minus 1 plus 2. Okay, the place value is 1, place value is 2. 1 plus 2, that is 3. 3 you can reduce. So this is equal to 255 dot 255 dot 255 dot 252. This is the subnet mask. What is the wildcard mask? 0.0.0.3 is the wildcard mask. So you have to see the topology diagram. What is the subnet mask they are giving? So based on that, you can take. Now I'm writing here 192.168.10.0, 0.0.0.3. Okay, 0.0.0.3, and this is going to be in area 1. Okay, so this is area 1. So I completed first router. Router 1 is over. I write for router 2. Then it will be more clear for you. I'm going for the second router. Okay, look at the diagram carefully. I'm going for this router, router 2. Same, there are 3 networks directly connected, but different area available. Okay, now you can see I am in router 2. So first thing is enable. Next, config terminal. Okay, so next one is I want to configure the process ID. That means router Ospf. It is going to be same for everybody. Okay. Now router ID. So the router ID is going to be different. So router ID here, let me take 2.2.2.2. You can refer our labs now. It will become very easy for you today. Now I have 3 networks. Okay, see network. So first network, I'm going here 10.2.1.0. So here 24 is the subnet mask. So the wildcard mask will be 0.0.0. Okay, so here 24 means it is going to be 255. This is the wildcard mask, and this is going to be in the area 0. Area 0. Okay, because area 0. Now I'm going for this. Okay, I'm going for the next one. So network. So this is the next network 192.168.10.0. So this is 30. So wildcard mask is 0.0.0.3 is the wildcard mask, and this is going to be area 1. Okay, sorry, this are the whole thing is area 0. So this is area 0. Now I'm going for the next one. So the next one is network 192.168.10.4. Okay, 10.4. So 0 dot, okay, here you can see 30. So automatically 3 is going to be your wildcard mask, 0.3. Okay, and this is also area 0. So I completed R2. Finished. So in exams, they will ask you to write the commands only. That's why I'm doing like this. Okay, now let me go to the next router. I'm going for the next router, R3. Okay, so here the same thing, 3 networks directly connected here. So the first command is enable, then config terminal. Okay, then I want to fix the router ID, that means the router process ID, Ospf 10. So 10 means in everywhere it should be 10, all the routers. Then router ID. For this router, so let us take 3.3.3.3. Okay, this is the router ID. Then network, there are 3 networks directly connected, 1, 2, and 3. So I'm writing 192.168.1.0. Again, network, you can see the second network 192.168.2.0. Then network, so here 192.168.10.4. Okay, 10.4. These are the 4 networks directly connected here. Then instead of wildcard, sorry, subnet mask, we have to go for the wildcard mask. So 24 means, okay, what when here 24 means 0.0.0.255. So this is 24. So 0.0.0.255. And this is going to be 30. 30 means 0.0.0.3. Okay, only 2 bits left. Now area. Now this is in area 2. So area 2, 1, okay. This is in area 2. So 2.0. This is also area 2. And then this is in area 0. Okay, finished. So same set of commands repeated, but here I taught you how to find the wildcard mask. Okay, finding the wildcard mask is very important. Okay, now please take a paper. Please take a paper /20 26. What is the subnet mask? What is the wildcard mask? Come on. If the CIDR value is 26, what is the subnet mask? What is the CIDR value? Come on. I'm waiting in the chat box. /26. I'm giving /26 as the CIDR value. Okay, for 26, what is the subnet mask? What is the wildcard mask? Come on. It means there are 26 bits available in the network, the remaining bits available in the host. So fine. Calculate. Okay, calculate the subnet mask and wildcard mask. Anybody? So I'm getting some answer, 255, 255, 192. Very good, very good. Keep it up, keep it up. Come on. Try wildcard mask also. Try wildcard mask also. wildcard mask of Gadir. Please try wildcard mask. Wildcard mask means just opposite to the subnet mask. 00063. Okay, if you want to check, please check 192 plus 63. 192 plus 63 if you had, okay, you have to get 255. Yes, so very good. Okay, we got some answers. Okay, really good. I will solve this. Okay, then I'll stop the class today here. So tomorrow I'm going to continue like this only. Okay, tomorrow what I'm going to do, Ospf in V6. Okay, how to write it in V6. Then I'm going for the switching. Okay, switching means like VLAN, inter VLAN. Okay, all these things today, tomorrow I'm going to give you a overall idea. So this is a recap. Okay, now see 26. 26 means you can divide this 8. 8 plus 8 plus 8. It is 24 bits plus 2. Okay, so all 8 bits is going to be 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here 2 bits, first 2 bits. The remaining 6 bits is going to be 0. Okay, the remaining, so totally 1, 2, 3, 4, 5, 6, 7. Okay, remaining 6 bits are 0. This is the meaning. Okay, so this is the meaning. Now, so if all is 1, that means 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the, okay, you add everything, it is going to be 255. Here, same 255 place value. If you add the place value, 255. Then here, if you add the place value, 255. And here you see only first 2 bits are okay, we are using the remaining 2 bits, the remaining 6 bits are 0. So 1, 2, 4, 8, 16, 32, 64, 128. So place values, I'm writing the place values 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. So 128 and 64. Now only 2 bits are 1. So you have to add 128 and 64 you have to add. So this is 8 plus 4 is 12. 6 plus 3. Okay, 9, 1. So 192. So the subnet mask is okay 255, 255, 255, 192. This is a subnet mask. Now, what is a wildcard mask? Wildcard mask is opposite to this. Okay, what is opposite? So 255 means, that means this you can minus, you can reduce this from 255. 255 minus 255, 0. 255 minus 255, 0. 255 minus 255, 0. This is 255 minus 192. Okay, 255 minus 192. So if you reduce this, okay, this is going to be, okay, 5 minus 2 is 3. And this is 5, so you can borrow 1, 15. So it is going to be 6. So this one, 0. So 63. So dot 63, this is called the wildcard mask. Okay, this is called the wildcard mask. So this is how you can configure, okay, this is how you can configure what is that, Ospf. Ospf in V6 is very easy. You don't need to do anything like this. Okay, that we will see tomorrow. So Ospf in V6, okay, that is we are going to, okay, that means IPv6. Okay, we are going to discuss, and also I'm going to explain to you about the switching concepts. Okay, about the switching concepts we are going to discuss in the next class, that means the tomorrow's class. Don't miss the class because these are all very important things. So only lecture number 13 is left. Okay, I'm going to give this as the video lecture. Almost tomorrow I will finish everything for you. Okay, so thank you very much. Okay, we may leave today. We'll meet tomorrow.